Hey everyone. Today we're going to be shifting gears to talk about Conda and Mamba, which is software that's often used to manage your software installations. So up to now, a lot of the stuff that we've been installing or using in Python, specifically the modules we're loading in, like argparse or math, a lot of those come pre-installed already. But what about packages that you need to install? So a lot of times when you're doing workflows, especially in, say, bioinformatics, where you have a DNA sequence and you have a reference genome and you need to align your DNA sequence to the reference genome, that requires use of a package that doesn't come natively installed on your computer or in your installation. So Conda and Mamba kind of help out with that. So I do want to go into a little bit about why I think you should use Conda. So I'm going to give some examples of what I have done to my life to make it accidentally more difficult than it needed to and why Conda could have solved that. So, namely, let's say, and this is a true and very recent example actually, I have an environment on my computer that I use for just about everything I do that's like visualization and basic like editing. So it's kind of like my general environment. So if I do conda env list, I have this thing called Jupyter Notebook R 4.4.2. And I have, if I say Jupyter Notebook, it will start a Jupyter Notebook for me. And we'll go into this next session. So just see the point I'm trying to demonstrate. Just now I have opened up my stuff. I have access to my terminal and whatever, it's fine. So it is able to run specific software packages using R 4.4.2. I'm going to shut this server down so it's not just running in the background. But I'm able to launch a server. It's able to use software. It's a Jupyter notebook, so it's kind of like an RStudio-like interface. And everything that I use is installed specifically in this path. So home, Vihagani, Anaconda 3, environments, and then Jupyter Notebook R 4.4.2. So recently, I was working on a project where Paula wanted me to do some gene ontology for her rescue genes. And there was one other thing that she had asked me to do. So I installed a package and blew up my environment. So good practice is typically when you're starting a new project, when you're doing something with an iffy installation, you create an environment specific to that project. But it's also fine to have a general environment like this where you just do most of your work. In this case, that bit me in the butt because I tried to install the package version and it's like, oh, this package that you already have installed is outdated. Would you like to reinstall an updated version? And I mistakenly said yes, and it broke everything. So I had to spend probably a week of my time reinstalling the packages, trying to fight back and forth to get everything back to the way it was before. And all of this was just because I had to have a specific version of something installed. This is actually quite a common problem in bioinformatics. You're going to be using, especially in R, in Python a little less so, but in R, package versions make a huge difference. So the benefit of using something like Conda or Mamba, which is roughly the same thing, or any sort of package manager like Pixie, is that you're able to have different environments. So I can have a version of R. Let's run that again. I can have a version of R installed here and a version of R installed here. And the package contents, like the actual source code, is physically being stored in a different location. And when I change between any of my environments, I'm actually accessing a different set of software. So I think if I say snakemake dash dash help, it says command snakemake not found. But if I say conda activate general, notice that this base has now changed to general because I have switched from using this software to the software that's on my computer in this directory. And now when I run snakemake dash dash help, it prints out help. So despite the fact that I'm on the same computer, my access to software changes based on the environment I'm in. This is really, really helpful if you need different versions of things, so different versions of R with different package specifications. If you're working on a different project that needs an updated version of something, or if you just want different, like if you just want to be organized and say, this is what I used for this project, this is what I used for this project. It really just helps manage what you have installed on your computer and not break things. So For example, there is a program called Max 14 that requires Python 2 in order to run. There's also, this is from Titus, but there's also a package called Sour Mash that requires Python 3 to run. If you wanted to use both Max 14 and Sour Mash on your computer, if you didn't have a package manager installed in any capacity, you would not be able to do this because you would only be able to have one version at the same time, unless you have them installed in different locations, which is functionally what this package manager is doing. Yeah. So this is storing stuff in different locations behind the scenes for you and managing it. Oy. So I'm briefly going to go through this list because I still see that it's kind of helpful. So some reasons that you would include using package managers is you need different versions or even old versions of software. You're working with a collaborator who likes a particular feature or software that's different from stuff you typically use on your own. You want to experiment with new packages without messing up your current workflow. This is largely what I did to myself. I messed up my current workflow by trying to experiment with a new package and it blew up in my face. If you want to publish your software, a lot of times it's good practice to have you export your environment so somebody can see what you ran. So, for example, if I go into GitHub, I can show you guys an example of software. So, let's say think Claudia RNA-seq. So at the end of this, I have documentation that says all environments and associated software versions are delineated below. And if you click on it, it will actually link to this YAML file that's directly exported. So it shows the name of the environment, the Conda channels that I used, as well as the exact dependencies down to the version numbers that I have. So I have bed tools installed version 2.31.1. I have all of these bioconductor packages installed that use these versions. So like Limma 3.58.1, Matrix Generics 1.14.0. So this is really helpful for keeping track of reproducibility. And there have actually been situations that I've run into where software has changed. One particular instance was I tried to recreate a chip-seq analysis using Bowtie, which I think, yeah, Bowtie 2, which is installed here. And I used 2.5.4, so it was literally this exact environment, but the authors had used 2.5.3. And in the patch, like the history of the software developers, when they updated the software, they fixed a bug that caused a lot of reads not to align. So the alignment percentages the authors had reported were like 25%. And when I did the alignment just using a slight updated package, I ended up with like 90+% alignment, which is a huge difference. But this is why software matters, because even using the same data and the same package, just the version number impacted the outcome. So it's really, really good practice to use something like a package manager. And then, yeah, another case would be if there's incompatible software packages. So, like some R packages are not maintained properly, so they're only compatible with R versions 3 point something, even though R now is 4 point something. So, it really depends. So, in terms of Conda, I really like this kind of breakdown of what Conda looks like. I think it makes more logical sense to me. So when you install Conda, it's basically giving you this anchor, this hook. And all you're doing is creating the infrastructure when you install Conda. It's just the environment manager. You're not really installing anything other than the installer. But it also comes with the root environment. So if you remember back in session 3, I had you use Conda to install Python. That's how we got you guys to run Python. So we see that it comes with a Python version X because this is by default installed in the package. And then you can install whatever other packages you want. Then you can make other environments where you can specify other versions of things, whether it's a different version of Python, a different version of R, whether you want to install SnakeMake or other packages that you're using. And you can basically keep all of these separate. So the installer that I had you run when I had you guys install Conda should have given you this root environment, which is usually denoted by base. So if I actually just open a new terminal, it should load into base. That means that you have Conda installed and that you're not in a specific environment. And it will already come with some stuff in the background, stuff that's used to commonly compile packages. And I think my favorite reason for using Conda is it makes package installation very, very quick and easy compared to other package installation methods, which include sometimes like downloading source code and adding it to your path as an exported path, or even like trying to download it on Windows as an application, but then it's disconnected from WSL2, so then you're not able to use it properly. So it's a little bit of a pain in the butt. So on the note of it being a quick way to install, we have installed Conda already, but I really want to switch us to using Mamba because Mamba is kind of an updated version of Conda that runs much faster than Conda does. So I'm going to send this, and I would like all of you to go ahead and run this command. Conda install Mamba. So Mamba is the package name. Dash N is the name of the environment. So you're going to install this in your base environment. And dash C is the Conda channel, basically where it's hosted on the internet for Conda to be able to access and install the package. And it's in Conda Forge. So you can just copy and paste this. Mine will probably say it's already installed. That's not what I wanted. So conda install mamba-n, and it's gonna run a bunch of stuff. And depending on how much RAM your computer has, how much storage your computer has, there's a lot of different stuff that's gonna happen in the background. So here it's showing me the available channels that I have in my base environment, the platform I'm using, and since this is a Linux-based platform, it's going to show Linux 64. And then it has to collect the package metadata. So this is all stuff that's hosted online. So basically it's trying to connect to this channel for this package and see what metadata there is associated with it. It says it's done that and then solving environment. In my experience, this solving environment portion takes the longest time. I have literally had it sit here for like 3 hours before, and I'm like, is it doing anything or not? Question mark. So like you can sometimes click enter to see if it's doing anything. Sometimes it works, sometimes it doesn't. But yes, that's why this session's going to be a little bit shorter because depending on everyone's computer system, it might not all be up to speed. So while we are running this in the background, I will continue to talk a little bit about this. So we're going to go through this process of installation together. And this is going to be setting up for next session. These are all going to be packages that we are going to use for data next session. But I want to show you that the Conda documentation is actually quite thorough. So if you look at the Conda documentation, which I've linked here, it tells you how to do just about everything you need. Pre-ChatGPT days, I was able to just do whatever I needed to using the documentation. So it's really well written, and any question you have, you can probably find here. So it tells you like if you want to create an environment, you say conda create name and then whatever environment name. It walks you through like it's going to ask, "Hey, do you want to do this?" You can say yes. If you want to install a specific version of Python when you're creating the package, you can do that by specifying the package and the version name. You can also create a new environment with the package installed at the same time. So this shows like conda create dash n my environment and install SciPy, which is like really common machine learning statistical stuff. Or you can create your environment and then separately install the package afterwards, which is also fine. So there's a lot of ways you can do things. There's very specific version control, which is one of the biggest benefits of Conda. You can create an environment file. So this will be your environment file, kind of like the one I showed you that I had exported from one of my working environments, and specify dependencies. And then when you create, you can say conda create dash dash file environment YAML, and it will install everything that's in this environment. So this is really helpful for reproducibility because let's say I'm on the cluster running some stuff for Nick's single cell data, and they ask, hey, I want to play around with this too. Can you please send me like what packages you used? I can literally just export my environment in one command to create a YAML file, send it to Nick, and they can install the entire environment themselves, which is really beneficial for reproducibility. You can list your environments using conda env list. So that's kind of what I was doing here. As I said, this can be like really, really slow. This is why we use Mamba. So if I do conda env list, it's saying with conda list my environments. So it says conda environments, and then it shows all the environments that I have, which is base, general, Jupyter, Seurat version 4, because version 4 of Seurat and version 5 are drastically different. So I was like, I'm not breaking my stuff, so I'm installing that somewhere else. That was before I broke my environment recently. You can also specify different platforms. So remember, I mentioned here when I was installing it, it said Linux 64 is the platform. You can specify other platforms depending on what you're running it on. So like if you are running it on a Mac, you can specify that, though it's not usually necessary. It can kind of figure it out itself based on your installation. You can specify locations. So this is really helpful because a lot of the stuff I used to do in LaSalle Lab on Hive, and I'll actually show you, well, take a little deep dive. I'm going to put my password manager not on my shared recorded screen. But let me log into Hive and I'll show you kind of what these shared environments look like. So I can say Hive, I'll log in, and I can say cd Quobyte LaSalle group programs.conda, and then do ls-al. So here we see there's like deepmod 2, GATK, NGS tools, which is like next-gen sequencing tools. This is kind of our default. Nanomethphase, which is a package. Epigenerator, which is a bunch of packages that are specific to um, like whole genome bisulfite sequencing analysis. So all of these packages are stored in this environment. And because I specified them using a prefix when I created these environments, let me bring this back over here. I said conda create dash dash prefix. I installed this in a central location instead of .ends, and that gave access to everyone in the lab to be able to use those things. So let's say one of the packages, if I go into ends, these are other environments. Notice there's a single cell RNA-seq-pi. And see, that's me right there. I created this single cell environment. Anybody who has access to this can say conda activate, and then actually we'll pwd so I don't have to type all this. So we can say conda activate single cell RNA-seq.pi. And now it will activate. So in the case of the example I gave with Nick's single cell data, if I said, hey, Nick, or if Nick said, hey, Vicky, I want to analyze my single cell data or take a look at something, can you send me the YAML file? I can say, I can do you one better. I can just give you access to the actual environment and you can activate it yourself. So this is something that they have done on Hive. So if we say conda env list on Hive, they have all sorts of environments, including like Sambamba, test systems for Conda and Mamba, Torch, which I think is some sort of like, I want to say machine learning environment. There's R 4.4.2, R 4.4.3. So there's all sorts of environments that the Genome Center, or I guess not Genome Center so much anymore, but all sorts of environments and software packages that the Hive administration team has now created for us. So if you're trying to trim your data, you can use cut adapt to trim the data. If you want to run variant calling, you can use GATK. If you want to do motif finding, you can use Homer. If you want to run a Jupyter notebook, you use Jupyter Lab. So this is kind of the power of having all your versions tracked and being able to use Conda, because all of them are now installed in a central location so that other people can access them. This is particular to shared cluster and compute environments, but you can also have your own environment with your own stuff as well. And that's what I like to do on my personal computer when I'm running stuff on my own. My Mamba is still installing. I anticipated this would happen, so that's fine. So yeah, you can specify a location for an environment, and there's other things you can do. So you can say like managing packages, and you can search for a package to see what channels are or what versions are available for installation. So you can see if there's a specific package you need. You can create projects within Conda, eh, and you can name it my project and have whatever channels and dependencies you want. And a channel is basically just like, let me see, managing channels. A channel, like I said, is just where the software is hosted. So typically there's Conda Forge, and this is, I'd say, a very common place that packages are stored. So Conda Forge packages are anything. So if you're using something as like an engineer or computer scientist, you might be using Conda Forge. But as stuff in bioinformatics started becoming more prominent with the advent of sequencing, people started using a channel that's called BioConda. So BioConda is a project that's commonly used with Conda Forge that has bioinformatics specific packages. So if I wanted to say Conda install, let's say BWA-MEM, which is an alignment software, and I go here, it'll say Conda install BioConda because the channel is BioConda, and then it will give me the name of the package. So one thing that I will say, and this is kind of jumping ahead since we're still in the process of installing Mamba in the first place. I guess let me ask, have you guys had it successfully install up to now? Like, can I move forward? Because I'm pretty sure I already have it installed and can just cancel my installation if so. Or are you guys still waiting on installation?
I'm a little
I think
behind,
I'm
but
pretty
go
good.
ahead.
Okay. It looks like coincidentally, as I asked that, it did install, so that's fun. So I will go ahead and clear this. So now if want to install stuff with Conda, I'm going to use Mamba instead. So see how I say like Conda install? In this case, I can literally just say the word Mamba instead of Conda. So I can say Conda create and then dash dash name, or I can say Mamba create. And Mamba is just an updated kind of faster version of Conda, but they can be used interchangeably. So if I say Conda create, we're going to create an environment that we're going to be using at the next session. So we're going to call this data analysis. So we'll say Mamba create dash dash name data analysis. And this is, okay, that was really quick. Point proven. So it says it created an empty environment at home Vihagani Anaconda 3 environments data analysis. Oh, I spelled analysis wrong. That's okay. We'll get there. So now this is listed in my environments. So if I want to, I'm actually just going to create the right version of it. I know depending on the version of Conda, you can rename things, but that's okay. So now that we have created it, I can activate this. So I can say Mamba activate data analysis. Conda activate data analysis? Watch me having broke my entire Conda installation. No, I did not. Okay. So you can say Conda activate data analysis. I think depending on the version you use, you can use Mamba or Conda. My stuff is kind of old because I've been running stuff on this computer for several years, so I think there's probably some sort of incompatibility going on. But the point was to say we were able to create this environment, we were able to activate it, and now we want to install things. So for the next few sessions, we're going to be installing a bunch of stuff that's going to be really relevant to the analysis we're going to be doing. So if we wanted to install some packages, we can say a few things. There's Jupyter, which is like the Jupyter notebook visualization. If you wanted to know how to install that, you can say Conda install Jupyter, and it will tell you the exact command that you need to install it. So see, it says Conda install Anaconda Jupyter. We can copy that, and I usually just like to change this to Mamba because it's quicker. So I'll say Mamba install Anaconda Jupyter, and it's going to print a bunch of stuff out. But that's how you find packages you want to install. So if you're like, I need to install SAM tools because I want to deduplicate my data, you can say Conda install SAM tools, and it will automatically pull up like this Anaconda Bioconda website, and it will give you the exact installation command, which is really, really convenient. So any Conda package should have its own dedicated Anaconda page with an installation and version tracker. So this will show how many people have downloaded it and what versions they have downloaded in like the past few months. So here we're installing Jupyter, and it's saying, hey, there's all of this stuff that you're going to need to install as well in order to get Jupyter working. So these are the dependencies of the package. And it says, in order to get the version of Jupyter you are installing to work, these are the versions of things you need to install, and there's 132 things you need to install. If you do not have space, I do not recommend doing this. This is going to take 143 megabytes of space. I know there have been some concerns about storage going on, so be mindful of that. But here I'm going to say, yeah, that's fine. You can install the packages, and it's now going through and showing that it's installing all these packages. So these are the ones that are being installed. And then it's going to link a bunch of stuff, so it's making it accessible, and then it says transaction finished. So notice it just installed in the background 132 packages and Jupyter Notebook for me, and I just had to run one command. So that's what I mean when I say that it's a lot easier to be able to do this. So similarly, if you wanted to install these packages, which we are going to need, so for next meeting, we need Jupyter, NumPy, Polars, and Plot9. You can also have them install all at once. So you can say Mamba install and you can run them one at a time, or you can just put them on the same line, say NumPy, Polars, and Plot9. And it will note that every single one of those is a package that needs to be installed. So you say Mamba install, and it says this uses Python 3.14 in the environment because that's the default version it's using. And yeah, that's going to take a moment to run and do its thing. Okay, so this is going to be the same thing we just saw with Jupyter, where it's going to print out like, hey, do you want to confirm like installation or updating these things? You say yes, and then it will finish installing. So while that runs in the background, oh, it did run in the background. It's going to say, sweet, here's a bunch of packages you need in order to make this work. It's 42 packages. Are you okay with that? And you put yes and enter. And it's like, all right, sweet, I got you. Let me download the stuff for you then. And it starts going through and installing. So we see that it is installing these packages. We specified we wanted pandas. We have matplotlib, which is a common visualization package in Python, which comes with polars. We have numpy, which we asked for specifically, a polars dependency, and now it's linking everything, and now it's done. So now, if I type conda env list, we see this little star denotes the one that's currently active. So we are in data analysis. Now, a really good example of using the documentation is I done messed up, so I need to figure out how to remove this. So I can go to the Conda page and say managing an environment, removing an environment down here. And it says Conda remove dash dash name, my environment, all. So I'm gonna, I'm gonna type this, and instead of my environment, I'm gonna put data analysis because I spelled that wrong, and it's gonna say removing all packages. Are you okay with that? I'll say yes, and it's like, sweet. Okay, I deleted it for you, and now if I do conda env list, I got rid of that package, that accidental creation, and now I just have the normal data analysis folder. So The reason that this is very important is because we are using this environment next time around. So next time we meet, please have this data analysis. You can call it whatever you want. You can call it like Python focus group environment. You can call it data analysis. You can call it ASDF for all I care. Like it's up to you. I like to name things in a way that makes sense to me. So like Jupyter Notebook R4.2 or R4.4.2 is the interface I use when I'm running R in a Jupyter Notebook using R version 4.4.2. Single cell RNA-seq is the package or the environment I use if I'm working on single cell RNA-seq data. If I'm using anything that's outdated Seurat packages, so this is Seurat version 4 and its dependencies, then it's Seurat v4, which is also single cell stuff. So I recommend, similar to Python naming conventions for variables, use something that makes sense. Use something that is actually intuitive and not just random so that you can keep yourself organized. So for next time around, I want you to have an environment, call it whatever you want, have Mamba installed, and install Jupyter, NumPy, Polars, and Plot9. And that's going to be important for our analysis next time, where we're actually going to start working with data and parsing it together. But yeah, are there any questions? All right, I will let you all get going then. Thank you for coming.
Thank you.